So I heard from some of you that the tangent of 270 was a tricky one. I overheard multiple groups talking about the tangent of 270. So I'm wondering, how could we use the unit circle, or what about the unit circle might suggest a way of evaluating the tangent of 270 degrees? Sam, what do we think?
Well, the way that I did it is I drew out a unit circle.
Draw the unit circle. That's pro tip number 1, is draw the unit circle. Always, 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 always. I do this still now. Like, I could tell you this from memory, but I'm not sure of it enough to not draw it. So, first of all, you got to think, where is 270 degrees on the unit circle?
Yeah.
And where would that be?
And it would be right along the negative side of the x-axis.
So that's 100.
Or the y-axis, sorry.
Right, because it'd be like opening up here. There's 90, there's another 90, there's 270, right?
Mm-hmm.
So this angle is 270 degrees, right? Okay. How does that get us any closer, maybe, to evaluating the tangent of 270 degrees?
Yeah, so then I tried to imagine that angle as a right triangle that goes if you had a right triangle in the third quadrant, it would, if you can just draw a right triangle in the third quadrant.
Like this? Like that?
Is that?
That's the fourth. Like this?
No, so just draw any right triangle in the third quadrant that goes to the unit circle, that has a vertex on the unit circle. Here, can I go?
Yeah.
So if there was a line like that, then I said that would be the opposite, that would be the adjacent, and as this moves this way, the opposite becomes 1, a length of 1, and the adjacent becomes a length of 0.
Nice. So we're thinking in terms of opposite and adjacent. So the opposite would be approaching 1, and the adjacent, right, which is the ratio that we're interested in, approaches and eventually becomes 0, right? So we would think that the tangent, if it were 1 over 0, what would the tangent be? Undefined, right? The tangent would be undefined. There would be no tangent. You would say, doesn't equal anything, or equals a little 0 with a line through it, which means no solution. Or you would say no solution, or undefined. Sam, I like your intuition. What I want to do is review sort of the key ideas behind the unit circle, right? Like what is the unit circle? Why do we use it? And how is it useful? What is it? I mean, sort of what's the point? Why bother with the unit circle? So again, if I'm thinking about the unit circle, and somebody's gonna have to help me with this. If I have an angle, and I'm gonna show it in this first quadrant because that's the most familiar way we know of looking at it. Okay? If this is an angle, then it's a positive angle because it's opening in the counterclockwise direction. Okay? So here's our angle, right? And we would agree that this intersects at some point x, comma, y, right? Okay. So how might I go about evaluating certain ideas around the sine of theta, or the cosine of theta, or the tangent of theta? What information here is relevant to those 3 points, and why?
Well,
Yes, sir.
Well, if you draw a line
Okay.
from the x, or from point xy down to the x-axis, then we can start looking for points. So, so if we know sine is opposite over hypotenuse,
Yep.
and we know that hypotenuse equals 1.
The hypotenuse is equal to 1.
Definitely. And
That's, yeah, the unit circle, thus it on the unit circle, yeah?
and then if x comma y
Yeah.
is y away from the x-axis.
Which it is, right? This point is literally the way we define points in a Cartesian plane, right? We would say this length is y, right? And likewise, this length right here would be x, right? Okay. So you're telling me that
So opposite is y.
the opposite is y.
Y over 1
Or what?
or y.
We made this point yesterday. It's a point we need to use today. That the sine of an angle theta, we can find, it's easy to visualize in the first quadrant, but it is always equal to the y coordinate at this point, right? No matter where the angle is on sort of the graph, or rather the unit circle, right? As this moves around, whatever the y coordinate is at this point is the sine of the angle. So even if this is our angle right here, this y coordinate is the sine of theta. Let's call it theta 2. Okay? Jordan, yeah.
Or the cosine.
Yes, sir.
The cosine is the adjacent over the hypotenuse.
Mm-hmm.
And because we know the hypotenuse is 1.
Yep.
The cosine is the adjacent side length.
Yes.
And the adjacent side length is x.
Correct. Nice. So the cosine of an angle, Jordan, is?
X.
I concur. Great. So there's another piece. Last but not least, the tangent. The tangent of angle theta. Yeah, Hannah.
So tan is adjacent or opposite over adjacent.
Mm-hmm.
So from that angle or from theta,
Mm-hmm.
the opposite is y and the adjacent is x.
Love it.
So it's kind of combining what we determined from the last
Mhm.
two with
Yeah.
sine and cosine. So tangent of theta is y over x.
Love it. Indeed. Thank you, Hannah. Yes. The tangent of theta is always equal to the ratio of y over x.
Or sine over.
Or, interesting. Yeah, to note. Thank you, Luca. Right, that, and this is cool. This actually shows us there's some teamwork involved. Props due multiple places. We like that.
Definitely.
Would be exactly the sine of theta over the cosine of theta. There's a funny joke that I can tell about this later. No. We wouldn't get it yet. It's a math joke. It's very funny.
But now the video's not going to happen.
All right. That's okay. We'll make another video. Okay, so these pieces of knowledge are key. All right? Because now I can use this fact and basically I should be able to evaluate any of these. So I'm going to pick one randomly. I'm going to say, okay, tangent of negative 225 degrees. Okay? If you did not sketch your unit circle for these, shame on you. You've got to sketch the unit circle. It cannot be done without a unit circle. I actually can't do it without a unit circle. All right? So be sure, and today when we're doing our exercises, sketch your unit circle. Okay? And, well, so where's negative 225? Where's negative 225? All right, yeah.
Would it be like at like so below 180, but
Well, so which direction will it open up if it's going to be negative? It's going to go down, exactly. It's going to go in that clockwise direction.
yeah, so it would be like
So there's 90,
yeah 90 and then like around
180, and then 225, right? Okay. So Okay, that's good. That is the angle. This is negative 225 degrees. If you need a primer on that, you can look to our notes or video from earlier. But how do I find, I mean, I like it. And tangent, we just said the tangent of an angle is always going to be equal to y over x. But how do I find that coordinate right there? How do I find the coordinates at that point? What figure might be useful to draw that we've seen before? Yeah, Aria again? Okay. Cesar?
We want to drop the perpendicular.
Love it. Drop that perpendicular. I love it. That's actually a great point. Wherever your angle is and you're evaluating, drop that perpendicular. If you're here, drop the perpendicular. Right? Hit that perpendicular down to the x-axis. Yes, sir. So we do this, and what information do we have? What information do we know about this? Sorry?
90 degrees.
This is 90 degrees. Correct. What else do we know? Correct. Do we know anything else? Any other information, maybe like about the angles or the side lengths? Yeah, Laurel?
We know that the angle with the x and y coordinate is 45.
Ah, indeed. If this is 90 and like this part right here is 180, then this piece left over is 45 degrees. Right? So now if I want, I can just, well, I don't know. Why actually why is that useful now to like have that piece?
Because then you know the side ratios of a 45, 45, 90.
Right.
Or half square.
Right. We know it's a half square, right? And we know that, right, so this would be like x and x and x root 2, right? Okay. But how does that help us actually find this point, x comma y? Do we know anything else? Any other information going to be able to help us find maybe one of these missing links? Hannah? Word. So x root 2 equals 1. So x equals 1 over root 2. Love it. Times a big 1. Because it's multiplying by 1. So that would be root 2 over 2 is your x. So this length right here would be what? In terms of x. Or sorry. What would this length be? This x length? Negative. Why negative?
Because it's going to the left on the x-axis.
Because this distance is negative. It's going to the left on the x-axis. Indeed, this would be negative root 2 over 2. And then what would our y be? Positive root 2 over 2. Indeed. Okay? So, here, off the board for 90. What's my sign of negative 225 degrees?
Negative root 2 over 2.
Is it negative or positive?
Positive.
Why?
Y.
Because y is the sign, right? The sign is equal to the y, so that's going to be root 2 over 2. Cosine of negative 225, you can just say it, negative root 2 over 2. Okay, and then the tangent would be what?
Negative 1.
Negative 1.
Wait, why?
Because negative root 2 over 2 over positive root 2.
Yeah. Well, yeah, positive root 2 over 2 divided by negative root 2 over 2 would equal negative 1. Interesting. Which kind of makes sense, right? I mean, what would it appear on the unit circle? Like, what's another definition for tangent if we think back in time? What's another? Yeah, think back. Remember, tangents came from slope angles, so tangent is very similar to what concept? Rise over run. Yeah, Carlo, exactly. Tangent, the tangent is literally the slope, right? It is the rise over run. Doesn't it seem that the slope of this line would be negative 1? Right? Right? I love that. Yeah, indeed. If you went like this, it'd be like down 1 over 1. Slope equals negative 1, which which is equal to the tangent of negative 225. Cool. Okay, questions?